Welcome to the Merlin and Metro News Network. Today's program covers the flap system. Outside of an occasional component failure, the flap system rarely causes maintenance problems. Now, let's roll our program.
The flap system on board the aircraft is used to control the positioning of the wing flaps. Hydraulically powered actuators provide the force to move the flaps, while an electric system both controls the flap operation and provides an indication to the pilot of the flap's position. The flaps incorporate a smaller flap attached to their leading edge called foreflaps. These devices improve the aerodynamic efficiency of the flaps. The flaps are hinged through the use of flap links that connect the flap to the wing structure. Each hinge point consists of a fore and aft link, each link being of different length. This difference in length causes the flap to move backwards slightly before beginning to rotate down. The center portion of each flap contains a beefed up area that connects to the flap actuator link. A casting is bolted to the flap to help carry these loads. A larger flap link, sometimes called the flap pork chop, serves as both a hinge point and a connection point for the flap actuator. The flap actuator is installed in a pivoting mount attached to the wing aft spar. As the flap travels down, the actuator must pivot up and down to stay aligned with the travel of the flap link. The flap actuator contains internal stops that control the total travel of the flaps. An adjustable fitting attached to the actuator shaft is used to set the retracted position of the flaps. Because of the serious safety consequences should one flap move and not the other, a mechanical interconnect is installed between the two sides. Two large walking beams are installed in pivoting mounts on the center wing aft spar. Links connect each walking beam to its respective flap. A bearing and bolt are used to join the two walking beams together. As the flaps move, the walking beams are also driven. The mechanism is designed so that even if one flap actuator were totally inoperative, the other actuator could drive both flaps to a symmetrical and equal position, even though this movement would probably be slow and jerky. Control over the system is provided through an electrical follow-up system that allows the flaps to be positioned at any position with detents at the down, 1/2, 1/4, and full up positions. An indicating system is provided to power a flap position indicator located in the cockpit. Part of this circuit is also used to activate the landing gear warning horn should the flaps be extended past 20 degrees without the gear being fully down and locked. This part of the circuitry is actually part of the landing gear warning system covered in another program, although the components are physically located within the flap control box. The electrical control of the system is monitored and directed by a flap and gear position control box located on the pressure bulkhead just forward of the pilot's feet. A potentiometer is installed in the right-hand side of the flap interconnect area that is driven by flap movement. There are two near-identical installations and should not be confused with each other, since the potentiometer on the left-hand side is for use by the SAS system. The position of the flaps, as sensed by this potentiometer, along with the position of the flap control handle, are monitored by the flap control box. The outputs of the control box are the flap indicator, which is driven to indicate the current flap position, The landing gear warning horn circuit, which will be activated if the flaps are below 20 degrees and the gear are not fully down and locked, and the flap control valve, located in the hydraulic power pack. The control box will activate this valve to the up or down position as needed, in order to match the actual flap position with that selected by the pilot. Internally, the control box includes the necessary electronic circuits to position the flaps in response to pilot commands. The control box features its own internal fault monitoring circuit that will disable the output of the control box should a fault be detected. Since this would render the flaps inoperative, the up command of the flaps is provided directly through a micro switch located within the flap control. This micro switch and associated circuitry entirely bypasses the flap control box and will supply power directly to the upside of the flap selector valve installed in the lower portion of the hydraulic power pack. The flap selector valve will route pressure to either raise or lower the flaps. Rather than being connected directly to the flap, this pressure is supplied to a device called the flap lock valve. Because the flaps produce an enormous amount of drag, there are speed limits for their extension. The farther the flaps are extended, the slower the maximum lowering speed is allowed. Exceeding these limits could place high structural loads on the aircraft and flaps themselves, with a structural failure possible. To prevent this, a device called a flap lock valve or flap blow-up valve is installed. This device accomplishes two basic functions. First, it locks pressure in the flap system until it receives a pressure command to unlock. Even if all hydraulic pressure were lost in the main hydraulic system, the flap lock valve will ensure that the flap remains in its last commanded position. The lock valve will also allow pressure to escape from the flap actuator, and thus allow the flaps to blow up if the aerodynamic loads imposed on the flaps exceed limits. The total travel of the flaps is 36 degrees. This travel is measured from the full up position and is controlled by stops located within the actuator, so it always remains at 36 degrees. The up position is determined by fairing the flap into the contour of the wing, using a flap rigging board. Within limits provided in the maintenance manual, the flap may be drooped as a means of trimming the aircraft. This is accomplished by lengthening the fitting attached to the end of the flap actuator. No matter how much or how little the flap is drooped, the travel is always 36 degrees, since the actuator's stroke equates to 36 degrees of flap travel. Another aspect of the flaps is the smaller assembly attached to the front of the flap called the foreflap. This unit is used to control airflow through the flap well and over the front of the flap. The foreflap acts to increase the efficiency of the flap, especially at larger flap extensions. The gap between the foreflap and the flap is adjusted using shims to correct for rolling problems with the flaps in the full down position. These shims, if required, are installed at the factory and rarely require further field adjustment, unless radical changes have been made to the flaps, such as major repairs or flap replacement. The area directly behind the engine exhaust pipe requires attention. This area is painted with a special paint designed to help reduce the effect of heat and engine residues. These areas should be kept clean and repainted as necessary, as an aid to preventing erosion, cracking, or other damage to the skin.
Well, that covers the flap system. It's a fairly straightforward system that does not cause very many problems. The biggest thing to remember about the system is the caution on crossed flap actuators. There have been many ruined flaps and many embarrassed mechanics because of crossed flap actuators. Remember, if in doubt, it only takes about 5 minutes to remove the interconnect bolt. It's cheap insurance when you consider the consequences. Until our next program, good flying and good maintenance.